Hello and welcome to the 2022 Winter Camp of Shiva Robotics Academy. Today's presentation.
Shiva Robotics Academy is a robotics academy where kids from kindergarten to 12th grade can come and build robots and develop their engineering and communication skills. We have the younger kids work on Lego robots, and then they can move and transition to Spike Prime and EV3 robots, which are robots that are made out of Lego pieces that run autonomously. And then they can move on to metal robots, which is our first challenge, where the students build metal robots that can function autonomously and with a remote control.
We'd like to welcome all the junior roboticists and roboticist seniors to this event. And first up, we have the Polebot and Riley Rover by Damian. I'm ready, Mr. Thomas. Excuse me. I'm trying to make this same code up here. Hi, Fletcher. I have to take away the numbers. Okay. Henry, we need to start. Present your mom. Well, there's technical difficulties. The Polebot was designed with a chain mechanism and a wheel mechanism to pull all of Santa's presents along. And here, Henry will explain more thoroughly about it.
The Polebot is made for carrying things, presents that can't carry real presents because they're too heavy and they won't fit in your bed. But just little Lego presents will work. It can carry Lego apples, but not a real apple that's too heavy. And here is my demonstration.
Well, that was amazing, Henry. Thank you so much for presenting your junior robotics project. And next up, he also built the Riley Rover, which is very advanced for its level, and I'm very impressed.
this is the Robotic Rover. It is not redo. You can see that it's bigger than the tadpole. Was like I skipped Spike Clan. It's for 9-year-olds. Not even I could put in this piece. My friend had to help me. I put on these 2 pieces, and it was really, really advanced. I was on like a spectacular thrill level, and here it goes. Hey, Fletcher, it's not working. See, I got it. Okay, wait. Is it? You know that I didn't even use the tablet because this robot can be coded in a different way. It's not on WeDo. It's on with like Wally, but it's not in Wally. It's the like it's a brand new rover.
All right, thank you, Henry,
The
for
brand new.
Good job. All right, thank you, Henry.
I can't believe that they had to present 2 models at the same time.
In the Robotics Academy, we teach students to do more than their level. As you can see right now, Henry did a WeDo model, which is for 2 to 5-year-olds. And then he did a 9-year-old model, the EV3. Alright, next up we have the Toy Sorting Center by Ashwin and Ben. Okay, wait.
Okay. Okay, my name is Ashwin.
It's okay, Bennett. Go ahead and explain.
I wasn't ready.
That's okay. Just give us a demonstration.
My name is Emma.
This pen, then first of all you put the presents, like, and then you spin. Oh, whoopsies. Okay, do like that. Just drop it. Okay, then it's spinning. And this is how it works. First, the present goes like straight to the side, drops down, then use it, and then you spin. So you use the spinner to spin the present in the correct side. If it's a green present, spin it on this side. If it's a blue present, spin it on this side. And here's the gear for it. This here. And first of all, before you start it, press the yellow button to make it on.
It makes it go. If you press the yellow button, it makes it go. The red button probably makes it stop. Probably. I don't know exactly.
And you know, it's go like this and then drop like that and then
Just put it in there. Go ahead. All right, thank you, Bennett and Ashwin, for your amazing presentation. Oh, okay, so that's Anyways, next up we have But we do Santa
That's not the
sleigh
right
and
one.
Rudolph,
It's the
By
other one's
Manu.
green.
Bo, and Alco.
Thank you. Let's say a name.
Stop it. Do you know how to stop it? Okay, so we're gonna preview. Alright, go.
My name is Radu. My name is Bo. My name is Okar. And today we build Santa's sleigh and Rudolph. This takes hard. There was a problem, but we fixed it.
Alright, thank you, Molu, Bo, and Joker for this amazing presentation.
Every time I should.
Now, next up we have Santa's Race Car by Vaughn and Yui.
My name is Tom. My name is Suar. And we built a race car.
My name is Vaughn.
My name is Suar.
I'm looking for the wall. The wall is starting to cut out 100 bits. Can you check? Can you hear us?
Back up.
Okay, stop.
Audio setting.
Hey.
Alright, thank you guys for this amazing presentation. We hope to see more of your robotics in the future.
I'm Fletcher. I'm one of the engineers, and for our FLO, we had to talk to experts. So we went to city council and presented our idea. So our idea is on the end of here, there will be like a kind of like a turbine sort of in the water. Here, I'll show you.
Hi, I'm Rochelle. I'm the coach of the engineering team.
So kind of like this. So like this is where you walk on the pier, and this will be on the side of it, like the pier, or the pole. And it goes down, and a wave will come and go against it. and and it generates electricity. So kind of like this one, where you spin it and the light goes.
So we went to city council with this, and the city council liked our project, and this kind of shows how FLL and First Lego League is not just about building robots, but also developing communication skills and presenting.
Alright, thank you guys for being so generous to create a project to save our environment. And I bet that windmill could power 3 cities. Alright, next up we have the Spike Robotic Arm by Charlie and John. Robot, so that when Santa comes, he can easily put the presents under the tree.
And the sensor is the push sensor. If you hold it, so if you push it, it'll close, and when you release it, it'll open.
And it uses one motor. And that's really it. Okay, thank you, Charlie and John, for showing us the way of the future.
You're welcome.
Alright. Next up, we have the EV3 Robotic Arm by Alex and Sean.
Alex. Hello, my name is Sean Lee, and I'm Alexander Batel, and we have built the EV3 robotic arm, and we will give you a demonstration. It's meant to open and close and use its robotic arm to grab it and then let go after a few seconds. So a little detail is it grabs it, pulls it in, and drops it, and repeating a method of grabbing it again and repeating it. Pulls it in and releases it. And we have done it on this brick. We downloaded it on this brick so we could use the coding as soon as it was with a press of a button.
Alright, thank you, Alex and Sean, for this presentation of the future. Wow, that arm had so many gears, I thought it was a grandfather clock. Next up, we have the Sanitizer Dispensing Robot by Ava and Isabella. First,
Ava.
I'm Bella,
I'm Ava.
and we built it the hand sanitizer robot.
It works like this. We built it so that Santa can deliver presents to hospitals without getting sick. Wow, that box scored more hits than the bomb of soap. Okay, next up we have The Spike Santa Sleigh by William and Arthur. This is the Robotics Spike Santa Sleigh. And it has a color sensor and 2 motors.
We built it so that Santa wouldn't have to walk around the whole world delivering presents. He couldn't finish it in one whole day, so we built a sleigh so he can do it much faster.
And we programmed the code into this box. We programmed it so it would turn. And it was really hard to build because it kept like messing up kind of, but then eventually we did it. Okay, thank you guys for showing Santa a better way to travel around the world. I'm watching that. Oh, he doesn't replace your phone, so. Sure. Alright, now we have the Easy Tree Puppy by Aiden and Alec. Sorry, first up. Go.
Okay, good.
Hi, my name is Alec. My name's Aiden. We built the robot puppy. The EV3 puppy has 2 sensors. It's a touch sensor and a color sensor, and it has 3 motors. 1 in here for this to move, and 2 for it to sit. I'm gonna show you how to sit. And it has. We're going to show you how it sits. That's what it is. That's how it goes. Bye.
Thank you, Aiden and Alec, for a new puppy. Alright, next up we have the seniors of Shiva Robotics Academy presenting their creation for the World Championship of Robotics.
Okay, so this is a partially finished prototype of what will be going on in our FTC competition. We have things like vision on this, such as this camera over here, which can detect codes and images across our game field. The kind of computer vision, along with our autonomous robots that uses mechanical wheels and all of these complex kinds of movement systems, is how we're planning on winning this FTC competition. There's all sorts of other things as well, such as these distance sensors, which using IR lasers that can focus in on different areas and tell us distance about how to move. FTC. Yeah. Okay, so if this were to win our regional competitions, we'd be able to go to World Championships, usually hosted in Houston. In Houston, teams from all over the world that have like won in their regional competitions are allowed to go to in Houston and like they compete against each other for who will become the World Championship team. At Houston, people were able to meet all kinds of cultures and ideas that came from all over the world. I've been there last year with my FRC team, and I was able to meet teams from Taiwan, Japan, and the Netherlands. All of these diverse teams can come together, and I have a lot of knowledge about what happens globally.
and also First Lego League is also has this event, and in Houston this happens from April 19th to April 22nd. And if you want to spectate this, you can email us at Shiva Robotics. The email address should be on the screen, so you can email us if you want to go and watch it.
Okay, thank you seniors for showing us the World Championship robot, the Beat. Alright, next up we have the Spike Super Cleanup by Oshwath and Lenny. Ooh, that's me.
Oh, true. So how this works is that, so you see, the motor will spin, counterclockwise or clockwise?
Okay, so basically how this works is this is a touch sensor. So when we touch it, this will close. But when we release it, it will open. We code it so that it doesn't need an iPad and can be done mobily. Okay, so we're gonna demonstrate now. So I'm gonna close it in.
Just a sec,
Yeah,
literal
1 sec.
technical difficulties. Sorry. Alright, it's fixed.
Alright, now I'll show you.
Okay, maybe try to get up like this. Good. Sorry.
We are very sorry for these technical difficulties. Yeah, I think you guys get the gist. So we built this to help Santa lift those heavy presents that he can't lift and put them in a sleigh or under a tree.
Yeah, like.
As you can see, its gripper is durable enough to lift an entire Christmas tree.
Well, if your Christmas tree is really light, and that is all.
All right, thank you, Larry, for bringing our project in and presenting. Okay, next up we have the Gemu Dragon by Ava, a complex and robot dragon to bring a warm embrace to the new year.
I'm Ava, and I built a robotic dragon. I can do whatever I want with this dragon by pressing a simple button. I can make him go forward, backward, I can make him spin, I can make him move his wings. He uses five motors. Two are normal motors you would see in most Lego robots, and the other three are in most machines you would see today. He can do this. And he also has moods. This one's happy.
Thank you, Ava, for showing us the most complex robotic dragon I've ever seen. Wow.
Yeah, it took me like 2 days.
And finally, we have the Spike Competition Robot by Fletcher and Damian. excuse us for 1 moment. Alright, we're back. And here we have Fletcher and Damian with the spike competition.
Damian will be here in a second. I can start on this. So, my name is Fletcher, and this is our FLL Spike Prime competition robot. So, on our robot, the main thing that we have is a moving wall. So this wall can go up, down, left. So therefore, it can pretty much go anywhere technically on a graph that it has, which is 135 by 315. So we can make it go to the corner, top corner, left bottom, and we can move it diagonal.
So it's a Spike Prime box robot with these 2 motors attached to these wheels down here, and then there's these 2 like spheres that it goes on.
Also, in our moving wall, this is kind of like the inside. So there's a motor attached to the actual wall that moves it left and right on these things. Then there's one right here that attaches to this one to move it up and down. That's it.
Alright, thank you, Fletcher and Damian, for one of the most complex spike robots I've ever seen. As you can see here at Shiva Robotics Academy, we teach students to go above their grade level and achieve many things, such as engineering, or robotics, or even a scholarship at NASA, SpaceX, or even any kind of astronomical thing involving robots and engineering. We thank all of the junior roboticists and senior roboticists who have presented and made models for this year's WinterCamp. We hope to see you all in the 2023 next year.